All right, hello. I'm Nate Allen. I'm CTO and one of the founders of PollenSense. Our name is PollenSense, but we actually make a particulate sensor that can measure a variety of things in the air. And so this is actually an image of what is in the air right now here on the show floor. This is our APS 400 sampler. And what this does is it kind of combines the traditional Hirsch style air quality sampler, where you're collecting air samples onto a tape, and it combines that with an embedded cartridge where it can continuously sample, and it combines it also with AI and microscopy. So there's a microscope busily working right now, and it's taking these samples, and it takes over 1,000 images and combines them across different focal lengths and lighting scenarios, and it actually does some 3D reconstruction to try to bring out as it can about these particulates. And then there's an AI running embedded in the device, and it can recognize what these particles are, and it reports this information up into the cloud. So in near real time, you can know, here's what's actually in the air. Here are the molds, the pollen, as our name implies, but also we're adding new libraries, and we're also adding the ability for our customers to be able to add their own libraries to kind of make the sensor their own. So we're working on an asbestos library and a silica library, which will actually allow us to expand into new territory. So for instance, for early warning, you could have this running at a work site. You could do perimeter monitoring, so you could have multiple silica models running, and it's classifying these as we go. So if I click on one of these particles, it tells me right here 98% chance that that's a mold particulate, and then I can see the data reported through an API. And so I have data over time where I can actually measure and report on that data. I could generate that report to the end user, or we also have a whole network of these sensors running outside, and you can sort of get a global model of what's happening with outdoor air quality. So we, just to give you kind of an example here, we're adding this asbestos. I don't know if you can see that very well, but we're adding an asbestos library, which, although we don't have a certification yet, will allow us to if you're working in a site where you might wonder about that, you could put this as an early warning system, because it's continually doing all this work for you. We also are taking the tool that we use for training these AI libraries, and we're releasing that. So again, if this I had somebody ask me earlier if it detects wood pieces. If you are looking for a particular particle type, particulate, you can add your own library and train your own library on top of the libraries that we've already built. We also have a companion app that runs with this, so you can provision a sensor. You can have multiple sensors report to the same site, so you can improve the amount of signal that you have to the amount of noise. About every 2.5 seconds, this is reporting a frame and sending it up to the cloud. So you can actually retrospectively look for particulates that you collected from frames that you collected earlier. So if you train a new library, you could go back and say, oh, was there this wood ash or something present historically, or maybe microplastics. We're seeing a lot of microplastics, all the carpet and everything in this room. So these are some examples of probably these are little fibers probably coming off of the carpet here. So this allows you to actually see the particles instead of just having a statistical grouping, a PM 2.5, PM10, just a statistical breakdown. We can actually see what they look like, which aids significantly also, as I mentioned, in building custom libraries, because you have a human reference. And to that end, we're adding a quality control mechanism so that you can basically have a person quality control your data that you got from the AI. So if the AI doesn't if you don't 100% trust the AI, you can improve the AI. You can by adding reinforcing it, but you can also have a human cross-checking what it is that it's reporting. So the ability to build your own libraries basically means this isn't just a static particle sensor. You can it's a whatever future detector with your own name, and you can see the individual particles. You can name them if you want. I'm of course joking because you're going to be thousands and thousands of images a day that are going to be reported to this. But we are going to be presenting. We have a breakout tomorrow. If you're interested in more details, you can go to that, and we'll talk a little bit about how we developed this sensor. Do you want to see inside the sensor real quick? All right. So there's a nozzle on the bottom. You may not be able to see that. I'll kind of bend it over a little bit. There's a nozzle on the bottom where the air is being directed in. Then it impacts on this tape, which is part of this cartridge. And then there's an embedded microscope. And again, this is busily operating. And then you have embedded computing that's running continuously. Okay, pollensense.com if you want more details.